All right, let's see here. I'm gonna be watering my parents' backyard while my dad just retired. All right, wait a second. Had to get that going. Shower was off. It wasn't quite on the. Isn't that spraying right? Basically, yeah. Point is, so Thermite. How did you get the Thermite? You used two inline fours. I thought this was a 2 liter inline six here. Oh yeah, I know, but it's kind of hard to fucking find like a liter size inline three from someone that does iron, which you don't really need that much iron, when you think about it, right? Like you wouldn't really need that much iron, right? So it's like, well, then you only need the carbon. If you want to go like you normal kind of style instead of like my idea, like a bunch of diamond like carbon that gets basically forge welded into sheared off diamond like carbon and standard carbon, and it shears off. Of course, we need molybdenum and chromium. We need like to harden the stainless steel, so like we have to forge weld in a way it out. But it's not really. It's kind of like a sponge. You know what I mean? Kind of like you use fiber, carbon fiber, right? Like you can just plate, but you don't really need a plate. That's the thing. You just go like, hey, here's a bunch of carbon fiber, bunched up in like a little ball. You sort of press it together a little bit, and then it's just like, oh yeah, no, because we kind of want it to be quite porous and break apart and diffuse very well. Yeah, like we don't really want it to be like all that put together. We don't have the ability to really kind of break that apart like we need. You know what I mean? Kind of not the best idea. So, anyways, we're all, hey, what if like we didn't do that? We did a smarter idea. We're all like, yo, graphite powder is pretty fucking cheap, probably. I get some charcoal, you know what I mean? Get a microwave kiln, maybe. Just fucking get some sticks. I have to hike anyways. It's just a thought I had. I haven't been doing it at all. But like if I could get a microwave kiln, I could maybe start on that. But this is a whole backyard tech. My parents have a backyard. I don't have a backyard. Probably work for this. I don't think they'd let me do it anyways. It's a whole thing. So, there's like this rock kind of area in the forest, it's got a bunch of gravel. They could probably just scoop it out, put it on the trails or whatever. I haven't, screenshotted where it is. I drive by every so often. I'm like, is there a gate that's gonna show up or something? Like, am I gonna have to worry about this? Yeah, it's all good. It looks fine, actually. Yeah, fuck yeah. All right, all right. This seems like it's open to the public. It's a bit weird. It could be for anything. I mean, I guess it's a kind of a camp. It's not. There's no real like burning here, anything around, and it's just a bunch of gray shit. You know what I mean? Like it's barren of most life. I could probably just cut that. Just, you know what I mean? It's like a weed anyway. So it's like whatever. Right. This is where I was originally planning to test rocket engine ideas out that I had. Right. It's like the spot, I found for that. There's no one ever really in there. Never really have to worry too much. It's in the forest. It's in a nice little quarry like depression. You know what I mean? Like it's all sunken in. There's lots of rock everywhere. Really hard to fuck that one up, you know what I mean? Can't store nothing over there, obviously. So, there's that. So, but I was thinking about Thermite because it's like, man, that engine and like, man, that could be like really cheap to do. All it would be is like just get a hole, just fucking let it rust. It's gotta hit it with a hammer every so often, some salt water. Eventually I get some solar panels, allow for some aluminum from the other engine to get in there. Two inline fours. Let's say we're just gonna make like in this instance, a V8 instead of an inline six. You know what I mean? We're just making a V8, right? Like first off, when it's inline, it's far easier to just cut that, like literally bore, with the fucking bore thingy that I talk about. Because all it is like here's your parallel crank, basically, yeah, and because you need the crank anyways, so you should probably have that to be fair. But like if you don't, it's okay. Like you can probably make one but you probably won't want to. I'm just letting you know. You probably won't even get to this point. That's pretty normal. Most people don't really want to do this. So they just want to imagine and hear a person talk about this idea he had, how it works. But it's like, okay, here, here's the idea. And I was like, oh, you have carbon just like mushed together with like fiber. It can work. Carbon fiber will break down pretty darn fast. Like, it's okay, especially when it's, hey, guess what we're doing? The one thing they never wanted us to do: succeed. We're gonna bore that fucker out, remember? The ramrod is essentially just a spinning, fluted in a way. This one's like a whole thing that I've been working on because, like, I don't expect myself to be able to ever do this correctly at all. First time, there's no fucking way. I'm gonna practice. So if I want to make one of these things, how the fuck would I make one of these things? Like, I need to get a pipe of steel. You know what I mean? I need hydraulic fluid. I need to go through the seal. You know what I mean? I need this to rotate a certain way. I need it to extend a certain way. I need it to not fuck up my crank in any goddamn way. I need this to be way fucking stronger than what that normally is. You know what I mean? Hmm. So I'm like, fuck the crank idea. Actually, I kind of like it, but nah. It's way easier to just get a hydraulic ram. Way fucking easier. All I have to do is rotate something. I got a fucking like engine. I get my own fucking like electric motor. I could just truthfully, there's a couple of ways to do that. Yeah. So I don't know, man. Like, it's totally doable. Yeah. And it's like, what do you mean it's totally doable? You should already have the idea. It's like, oh, if I already do, it's just I don't really have one solidified yet. That's the thing. Like, times change, money, when you have the opportunity, what's best for you at that moment. That's what you do, you dummy. You fucking little stupid dummy dumb. You keep it in. You keep fucking figuring out another way if you can fucking find out how to do it faster. That's what the fucking shit this is. What are you fucking on about, you little fucking weirdo? What are you doing? Why are you gabagooing? Get out of here. Don't you know how to fucking plan for your future long term, you little bastard? Don't you have plans? Don't you have hopes? Don't you have dreams? Come on, give yourself. And if that helped any of you, fight some of those shitty ass voices inside your head. Go ahead. Write in the comments, man. But seriously, they suck, don't they? They came from people that were terrible in your life. You should really erase them. They're not worth it. Those fuckers suck. They're the worst. So, moving forward though, so like, all right, well, here, electric motor, you can probably get junked. You can probably strap a few together and get a belt to drive one center thing. You know what I mean? Like, come on, right? Like, oh, I can't get like a basic pump, hydraulic fluid pump, or a couple of those. You know what I'm saying? Like it's so bad, it's so hard. There's no way I could never. Oh God, what is this? The entrance to a fucking porn? Jesus Christ! It's so hard, it's so bad. Daddy, I would never. Oh, I could never. Oh, get out of here! This is how you talk to yourself. Get out of here. Maybe how about maybe I could do this. Maybe this will work. You know what I mean? Like maybe that'll work. Maybe that happens. Maybe that's how that works. How about like, hey, how about this thing? You know what I mean? Like, yeah, I don't know. I mean, I have to work about like on that. Yeah, Craigslist might provide. That's true. You don't have to ever go like brand new. Nah, it's not worth it. Like, it just needs to pump the like even a fucking lawnmower engine with a fucking electric motor going. Let's do it. It'll still do better than like. I have to spend $5K. My God, $1,000. What the shit is this? I know I have this idea in the future. I might do this again. I might. No, 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 no. You even got it. You didn't even do a spoon yet. You have to do a spoon. You need to do a spoon. You haven't even done the spoon yet. Like, screw this whole I dug a hole in my backyard business, bitch. Screw all that. Do a spoon. Get that one done, huh? How about that one? How about that? And I'm like, yeah, I'll get to it. I mean, I have money to buy thermite other than like my fucking necessities. Screw you, bitch. Oh, I know where I'm going. This is for absolutely all of you that want to follow along at home. Be careful. Don't just gung ho into this. Fucking do a spoon. Jesus Christ. Also, here's a fun one for anyone that might be considering trying this. All right. It's not the spoon idea, except it actually is. It's called alloying by thermiting. That's right. Certain metalloids and other metals can be 100% oxided and still work with this, which is great. But what that means is, of course, they have different temperatures at which they'll start to do this. So you need a bridge bond diffusal layer, if you will, for your thermite. That helps lower the total temperature for this to actually work and occur. That's a great thing, except they will always precipitate out of solution, and you want that. Because you gotta remember, even though it's a liquid and everything and it's metal, it doesn't really change that. That's all it is. It's just a solution in a beaker. It's just a stronger beaker. That's all it is. It's just a metal kind of like chemistry that we're doing, you know? Not that bad. You know? Just doing our thing. Some chemistry. With very large amounts of heat that will destroy you. So, be careful, right? Treat it like it's sulfur anhydrous, sulfuric acid. As if that exists, I don't know. You get the general gist. Really super concentrated, oh god, piranha solution, sulfuric acid. Oh, did somebody spill some, what is this? No. No. Don't worry, it's like Drano, it's very alkaline. It's a whole thing. Oh, really? Oh, it's just liquid lithium? You just have this lying around? No, 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 no. It's just that it's liquid at, close to room temperature. It's just slightly warm. It's got 9. I don't care what it has. It's not good. Yeah, and it's true. Super not good. Oh, who just keeps around a lithium, some liquid that's just slightly warmer than room temperature? Yeah, it's held under pressure though. Really is an old ass idea I had for a refrigerant. I was like, man, lithium would work. Lithium could totally work. It just needs the phase change. I mean, it needs to be bound in a pretty highly alkali like mixture of metals and like, other things. But like, yeah, that means I can mix a couple of solids together to get a liquid. As, as long as it's under pressure or remain that way, it's just slightly higher than atmosphere, which is pretty nice. And then here's the kicker. Oh, it's because I was going to do a small geothermal. Yeah, I was just going to drill down like a small way. You know what I mean? And then, I'm just gonna like do this like inner and outer tube. So like I just sort of get the outer side, all warm, right? And then there's this colder inner tube, dude. And all I have to do is just have it go down and it refrigerantly like just expands towards the inner tube. It's like here's a bunch of piezoelectrics in it. It's like why piezoelectrics? Oh, diaphragms are like reed valves for different pressures at different depths. So that way it can bleed off correctly and get the most amount of energy for the least amount of heat possible. That standard business of like everybody just starts doing that while they're in a fifth mental health hospital stay, and then just with it, right, at the fucking only homeless quote unquote shelter. It's a mission. It's not a shelter, it's a mission. Uh, and a whole bunch of other stuff about that, and bed bugs, and how you have to make points and everything, and you take a third of your earnings while you're homeless living there with bed bugs, doing a lot of chores around everything. It's a whole thing, really irked me. Yeah, but yeah, it's a whole thing. I had to work on something. And there's this redditor that was all like a dick about like this idea with a refrigerant engine, and then it came out anyways. But yeah, they can still make some power, but where they're testing clearly is not like the best place to showcase like a very large game. You know what I mean? There's not a lot of latent heat energy. They're pretty far north. You know what I mean? And this would shine in much higher altitude and an actual like you know kind of things for certain solar reflectors or just passive thermo siphon like designs for standard solar panels to any number of like other kind of like you stick it to the walls of your home to just gain energy if you want to cool it down, allow for it to expand. It's a whole thing. Give me a second. Unable to get audio for the from the microphone for a while. All right. So now I'm walking my dog in the park. So there's quite a bit of time here that has elapsed. And we're going to see if I can remember where I left off. Where it's like, all right, well, regardless of the fucking way that we're going to get, heat to get energy from the ground and all that, you know, piezoelectric and so forth, and you never really drill that deeply anymore, you know what I mean? It's like, this was just strung together from a refrigerant engine together with like this windmill kind of thing, because then it'd be easier to basically get it to expand that refrigerant and then have it come back down after it condenses. And I can get a lot, deeper in terms of the heat total I could get away with, but the materials necessary weren't going to be as like expensive or as uh yeah, kind of like built to go that deep. It's basically what it is. They don't have to be as strong. You know what I mean? I think that means we can get higher thermal conductivity, the whole thing, uh, which allowed for us to cool. Well, us would have been anything that worked with me. But it's like, yeah, so allows for us to cool from the windmills that can now float because that's the thing. Yeah, can do that. Cool stuff, right? It's like, hey, remember all that heat from below? Nice cooling tower sucks it up. It's like, if I just hollow that out and put it in the right diaphragms, guess what? I can use piezoelectricity again. And that's like a windmill, it's upside down. The cooling tower, nevertheless. A bladeless turbine, if you will, that cools everything. It's like, now it's just got a bunch of rings of these solar panels around. Now, the structure needs a hell of a lot less actual, like, support when it's buoyant. Like, that helps it be able to dynamically move into the wind better. But mostly the sun, you know what I mean? That's a whole thing. And since it's electricity, it's 90%. And then you can get 90% from that 90%, and that gives you 99. And you get 90% from that 99, you get 0.9. You can keep going, but like, yeah, there's a limit, It's never gonna really get there. So instead, it's like, what if I were to just do more trickery with the air and like cleaning it and, got a liquid going through so that can kind of like increase the way that, these things called solar panels work, right? Like the efficiency gives it the right charge, parity, or dipole, or any number of nice little tunnel increased likelihoods and transfer of field affect transistor-like reductions of resistance to various light wave photons. So I can capture more of them more efficiently, while it's also remaining cool. and self vibrates and all the rest of that. So, kind of a thing. You always need to cool those bad boys. Well, here's a way to do it. Granted, that's not where it came from, right? At first, it was just like it goes down to the ground, it's cooling it. But that is a whole other thing because then I can capture some of that good, sweet air water you call humidity, right? Well, I got a solar panel, and it's like, oh, okay. I can keep cooling it consistently for cheaper and cheaper. All I have to do is just change the sizing of the pipes that you use. Yeah. You gotta break them out. You gotta use them to your advantage. You ever heard of Jules Thompson cycle? You ever hear of like Venturi? You ever hear of like, I don't know, papering anything? How about like fluting the inner diameter or something to get it to go and, speed up? If it's perfectly smooth, it's not actually better. There are many different inner diameter structures that you can create to your pipe that give you a better result to help you with compression just from straight up condensing it, it's absorbing and all the rest of that. As those are thermodynamic properties. You can use heat like a thermosiphon. It can both accelerate but also compress and change pressures. Also with cooling, so now it's just a bit of piezoelectricity in there, and especially in those fins and more, you get all that back as it automatically does it. It boils off and automatically does it. It takes no energy to do everything you need it to do. Just gotta get close enough, yeah. So now I get all my solar panels and all my liquid, all my things. But that's a whole other thing. Nobody's apparently liked that one on Reddit. They're like, it's not going to be more power dense. There's a loss between the transfer between this given material and that. Yeah, that I capture 99% of it. What about you? Fuck you, bitch. You didn't say that. Yeah, I wasn't going to. Back when I was bargy pasting, posting on Reddit. I was older. Yeah. Just got out of some places. Trying to figure things out. It's the whole thing, Kept working on it. That's why that particular video exists after explaining or just before explaining lore and reality. That's still in there. This very story is still in there. Like this, I hate you guys. My idea is awesome and I know it. You're just bad at execution. Get at my level. Look at you, lame brains. Smooth over here, can't get a fucking atomic difference. Holy shit, can I get a Rydberg atom? I need at least an expansion of my electron orbit. Holy fuck. What is this? So fucking smooth. Field perfect. Boom! Impressive for whatever made you that stupid. Egotistical, maniacal garbage. That's nowadays, though. I feel good about that. Point is, I took it to heart. I'm like, no, you're right, though. We'll lose things in between. You're not wrong. Yeah. Besides, they're supposed to capture waste heat and actual extra from our atmosphere with the help of batteries to just be a range extender. Since a little tiny engine, more specifically a really good efficient turbine for this, would complete a Starling cycle and a solar panel on your back. It's totally possible, like your rear fender, right? Just sticks out a little bit. It's totally possible though. I'm like, I could get piezoelectrics now. That's what I think about, you know what I mean? So it's like, I can get piezoelectrics now. It's like, okay. I was like, what does that really mean? I didn't know much about them back then. I remembered them being a thing, but I didn't remember how they worked or like how I could integrate them. So that wasn't in my head at the time. What was in my head was Thermodynamic mean expansion, and they go less spinny spin, and they go more directive, all unified force. That can align things and allow for lowered total value of chaotic and quantizable heat to macro-sized, more field-based chaos theory mathematically spheroid exchange diffusal heat. So, that's what I was dealing with, besides like my first thoughts on like how to make like a fusion engine and reactor and all these other things. I had to do something. So I just journal everything, So it's the whole thing. I had to work on something. It was really boring in there. Yeah, I had one time I was doing a comedy bit, right? Everybody's laughing. This person comes over. Like, we don't, some of them might be offended, so I hate Republicans and doing that. You know what I mean? Those that know, remember, Folger's in your cup. Whole thing. But I doubt they're there, you know what I mean? But yeah, no. And I made friends with a guy that said I helped him out, not want to, do everything he was going through, right? And it's like, hey, nice. And we became friends. We actually did, for a while after. Tried to help me out, but he was again going through shit. But there's like a comedy club over here in the casino. I guess drive now. I don't know why I don't want to do that. It's just easier when you have someone else. Besides, guys, he's he's there, right? But like he's like me, and he needs help, all that stuff too. So we were just shooting shit. We eventually fell, away from each other. Shit goes on. So there's that. But there you go. It's like, here's your thermite, all right? Goes into your hole. Say, hey, you want to test your spoon, right? Say, here's how to alloy that steel. It's like, yeah, no, I know you want graphite in there, but you actually shouldn't use graphite. Don't do that. That'll just steal the oxygen from it. It's really not a good thing. It just takes the fucking graphite from you. You can always put in more if you wanted to. You might achieve a good result. It's sort of a thing. But instead, what you can get away with is a different oxided metal that happens to have a carbide attached, meaning a carbon or two attached. And that'll work just fine, so long as you can also get a metalloid in there. And this is your diffusion layer between your high carbon steel with a little silicon carbide, if you will, which you can absolutely pick up. And you can definitely use a little nickel if you wanted to. All right. As a nickel carbide does exist, but you don't really need to get it. I mean, it's not the oxygen so much, like, because it's really at this point, you actually need to do more when you want to alloy these as it goes through its whole melting phase. You have to have a diffusion, is what I call it. It's like diffusion bond layer. But that's essentially what it is. Under this condition, they make all these little areas much more willing to actually melt, right? They lower the temperature and they allow for them to fuse. They act as a catalyst during this. So they both get to a lower temperature to get to melting, and then they bond more readily, basically. Better. Yeah. So that's the thing. What those are almost always a metalloid. Uh, Granted, that's just because they're close by. So it really depends very heavily here. That's the shit part. That's I like that. Yeah. 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 Well, nothing that's going to be a higher temperature. Yeah, so magnesium is what I used in my video for a reason. It's an alkali metal, and you don't really need to get to a very high temperature for it to really do what it needs to do. And since it wants to share an electron, that means it's very repulsive to certain oxygenation continuances, we'll say. They like to electrify the whole pot in a way, effectively. Which means they would try to oxidize, right? But they act as like you did it too hard. Ow. And then silicon's all like, yo, buddy, what? along with a couple other things there for what it's worth, depending on what you want to do. Please go look this up. Try a spoon first. Oh my goodness, right? This is going to be hot and it's going to emit, well, vaporize off a lot of really bad, you're going to die if you breathe that in stuff. You probably don't want to do that. Yeah, this is an outside only deal. Don't do this inside. And if you're, aware of that, like I am, then you probably are good to go. You're going to look this up, right? You're not just going to like wing it, right? You're gonna think about it before you do it, right? Right? Like I have many times. I'm just talking about it now because I'm bored. Just want to make a video. You know what I mean? It's like whatever. This is pretty obvious bog standard stuff. It's not that hard, right? But it is for others. Like a microwave kiln will not get you the same result because this is electrically speaking, chemically speaking, a thing that we are doing. Instead of good boy phaser, go poopy, go potty, as you are. Instead of something else, right? Where in a microwave kiln, you're energizing, you're like making all of it alkali. And then it goes, yeah, whatever. Guess I'll just. And then it starts doing the dance of the chaos variety. So, fun, but that doesn't really help you. You can't control it. You can't precipitate it the right way. You can't have it react the right way and then undergo the final phase, which is, oh, you remember that? That's kind of like flux, basically, that you put on, right? Like when you want to weld something or any of that, right? Well, it's essentially what this is. Boron can definitely help. You know what I mean? Because guess what? It removes oxygen. That's right. It does. Yeah. When it undergoes I'm going to be so much more liquidy, I'm going to be way hotter, and actually I'm way lower temperature when I do this than I normally am, but you don't see that. Instead, what you see is a whole fuck ton of some gases trying to escape. But they don't have really a lot of ways to do that. So, when this oxygen is present, it'll try and form a bond still. So this one gets in the way. It's much lighter than oxygen, literally by mass and electron orbit. And it wants that fucking electron you got, bitch. Get it! Give it me, you fucker. Yeah. Boom. Eyes. I got that electron. There is no choice. But what it does is it clumps oxygen together, almost like a soda bubble, right? But while it does so, it also does something really interesting. It can exist like this. So it can nucleate finally, and then be repulsive to that which is the metal inside. Electrically, it is incredibly repulsive. It's like, chemically speaking, the wrong molecules you're trying to like dissolve together. It doesn't matter if they're both nano-sized. They're never going to do it. But that's very helpful, right? That means all you have to do is just leave it there. Of course, I don't do much more than hit it along the sides. Remember, foaming this bitch is a scary bitch. And don't do that dangerously. I always use 2 plates. So if you don't know, that means it's like I am plastic molding. That is right, yes. You heard me correctly. Because it's way easier to do. You have to dig a hole, I have to put clay, I have to bake it in the hole, I have to do a whole secondary bake thing. That's a whole thing, you know what I mean? It's a real actual like good thing to do. But like what that means is, of course, that you have to plan accordingly for your given amount of total iron and aluminum. Now that gives us ocean water or any salt water. And here, nitrogen filter. Oh no, where did you get this? And then it's an oxygen pump now into the inside of your solution. Then the solar panels that are here that can reflect into the solution. Right? Here's the cooling. Oh, the thermosyphony cooling of the pumping. That's right. Bitch, you thought this was gonna get easier? No, no, no. You need to make this a fucking oxide the right way. You could just buy it way easier. Yeah, be honest. But like, also, you get to hit it with a hammer, like in your backyard, just like swing that bitch. You're gonna break it up anyways, right? So like, we're just gonna oxide this. Boom. I just want to fucking take some aggression out. Honestly, it's a thing. Yeah, like I need to do it. But I gotta put in the bacterial sides and all the rest of it. It's like it will slowly try. You know, those extremophiles, man, I gotta tell you, crazy. Like for real. Yeah. So anyways, it's all like, yo, fuck you, bad Freon bitches. We ain't doing that shit no more. Hate you. And we just have to keep hitting it for a while, right? But it's like, oh, okay. Well, yeah. And slowly after a couple of weeks of continually doing that, it's going to be a bunch of chunks, most likely. Now, as you electrify it more and more aluminum on one side and iron on one side starts to happen. Now, the reason for this is because we're creating a bit of a circuit for a good reason and cause. It's a basically charging up of an electron redox flow battery, is what we have right now. It's a heat iron redox flow. MIT made one of them. And in fact, you can make this pretty easily into one of them in your backyard. You have clay. You have the ability to use that clay and some basic stuff like, oh, I don't know, this thing called boron and carbon, a little tungsten here. You don't need like a lot, actually. In fact, you don't even need the tungsten, to be fair. Silicon dioxide, so quartz will work just fine. Totally, pretty darn easily. But that means it burns and it goes, the oxygen diffuseth through. Oh, and they slowly go back into solution. Yes, well, unlike yours, which is liquid metal, this one doesn't need it anymore. That's right, that's why I did this. Deal. That's scary, bro. I don't want to deal with that. So, this is going to transport as a catalyst, but it's not really. It's a fuel cell that's contained between each other. But they undergo thermitable reactivity. It just takes an initial start to it, and the conditions have to be maintained, which is why it's sort of more like a Stirling engine. It will go over there, and then over there, and over there, and over there. And there's an optimal number of plates and diffusals and shapes for this given battery, so it can do it more efficiently. Those are just a bunch of tubes, though. If you don't know, the most efficient is a bunch of like cylinders, basically, and some plates inside. There are hemispheres that intersect, create like a Venn diagram point. Yeah, and because it's like a bullseye that goes in with that in there, it allows for you to shape the flow of everything and diffuse it better. So the oscillations can just continuously flow in a highly orderable way. Well, it does work energy, but that's because we need it to oxidize still. Yeah, that's the whole circuit. So this is more like a flywheel battery, and so the bigger and bigger it gets, the more and more you can take out, while the battery starts to slow down. Now you can always add in more heat from somewhere, but of course, you're a dumb one, looking at the screen, scratching your head, saying, that would work now. Watch, of course, as the animal does this. I didn't like that. Don't worry, I'm among you. I just wanted to be a dick pervert. Just a second. It's nothing like a little bit of a good jab, a good little ribbing. It's okay. It's an old one that I've got, quite old. It's from back in Chandler before I ended up in a mental health institution, or, well, inpatient institution, the first time. Well, since I was a child, yeah. So it's like, oh, okay. But you know what that really means? It's like, right, yeah. Look at these huge liquid batteries. They're like big old tanks. Like, what the fuck can I put in this thing? How the fuck do I make this better? This shit is bad. You suck. Fucking inefficient. Wonder if I can make field effects as it moves around and does electricity. Let's get this infill here the right way to make that happen. As different reactions happen at different points and constantly move around. The consistent sinusoidal like ring bandy, turbulenty, almost like flow of liquid. How can I mix these things the right way? Well, turns out it wasn't that hard. It's just rotating it and allowing it to flow through as it rotates. Yeah, through thermal convection. It's pretty easy. It, what? Yeah. Think axle through center of cylinder. Rotate 90 clockwise, counterclockwise to axle. Allow for shear effect and turbulent vortex to come in, opposing perpendicularly. Inwards or outwards, basically. It's essentially a bunch of little torque converters, right? That fire towards each other the right way. Pretty simple stuff. I eventually got to piezoelectricity back then. And then it went, I can get a lot more, especially if I add in a vacuum and allow this to exchange in no real way, but increase the oxidization thanks to cooling and having a charge difference flow through statically, along with an electromagnetic for how I can flow that through, along with these light waves that can still pass through in this kind of a shaped structure that will block sunlight, absorb sun, but then also reflect some of that and destructively interfere towards that which is already heading deeper in. So I can make a multiple layer capture device for sunlight and all the air in between, which vibrationally speaking, I can still run that through. And of course, it's always going to be there. So I got to account for the static and like, electromagnetic vibration shit heats up, cools off. I got the piezoelectric, sure. But what it really means is, oh, well, that's fucking a lot easier, actually. I can much more simply make this output a fuck ton more power. And that's my QVP. So it's like, all right, so quantum vacuum pressure, otherwise known as quantum foam in some aspects, absolutely has some amount of something. All I need to do is get it to trip a decently delicate balance. And that goes from an exo to an endothermic. From an exo to an endothermic, it then constantly tries to rebalance itself based upon more and more capture of quantum foam. It's a static flywheel that'll keep doing it pretty consistently in a total vacuum that doesn't input any more energy. And then it'll continue to get more and more. Now that has to come from somewhere, so it's quantum vacuum pressure. That means I made an engine that works in a vacuum, technically forever. I still have to repair things, but it's what it is. Almost actually perpetual. And I'm the only one that has ever done it. As a concept that will work literally right now. It's just about scale now. Look at this. It's a tiny nanometer transistor that makes it work. This tiny nanometer transistor, 100%, can be scaled to the size of the planet if you want it. Cheaply, too. Of course, we lost the planet, so is it that cheap? Yeah. Just a full, totally controlled planet that we can eat anywhere we want. Well, anyways, point is, we're talking about engines here. So here's the smallest heat engine theoretically possible with thermodynamics. That can be used for work energy. It started off as thermite. It's a thermite engine. That's right. And it's still a thermite engine all the way down there for quantum foam getting fused. Together, you want to do that one. Grabs little tiny holes. Passive structure creates holes the right way. Quantum foam comes in. absorb that shit. Of course, you gotta get real good at removing all of the outside sources of noise to check that one. You know, top two or something. Still works in our, what is this thing called? An atmosphere? No, you'd never want that. Uh-huh. Oh, but then you're talking about like a piston-driven engine. Oh yeah, no, I am. I'm just being a dick. I am, yeah. Yeah, I gotta go drive. So, all right. So I'm back at home. Well, not really. It's my apartment. But anyways, it does feel like that. So it's like, all right. Well, actually, I wanted to talk about how to actually genuinely do just an engine, an actual piston-driven engine. Okay. But the reason why I wanted to talk about the whole clamshell to mold process is because, yeah, you're probably gonna just want to get some clay from your backyard or just get clay in general. And then you need to put graphite that way together in the right spots so that it can diffuse into your burning metal. You know what I mean? Like you need the metal to do its thing, right? Yeah. But like you need it to do it with that in the area. So as it melts and it starts to try and alloy, you can plan ahead and say this amount of heat is likely there, even if it's preheated, it will still likely have about this amount of heat, right? But you need to put argon in there first, okay, when you do this, so that way it can reduce the amount of oxidation you might have to endure that can come back in and steal some of your carbon. All right. But that's also because you're going to reintroduce some of that, right, back in. And you do want that aluminum, like I talked about, right? Now, that aluminum is really important, right? Mostly because it's one of the easier methods, right, to get it to bind to your your sleeves. You're only doing enough iron here to make all your sleeves and your bottom bearing area and to be nice hardenable steel. Okay. You want it to be a good Mohs hardness that you can cast out by doing this, but it takes energy, of course. So that means you need to lower the amount of temperature, right, to get it to do this. During this reaction, however, as I said in that video, I'm ramrodding the hell out of that in, with this little graphite. So I was like, hey, I'm going to build up. I'll get this little, like, effectively, it's almost like a board. It's not really. It's just a tapered in to a point, and then we have to do like a little fluty, but then it's just a spin smooth guy. So it's like, we're really not trying to actually do what you might expect. That's just to help it grab and push it down, right, as it spins. We want to open up that hole. Okay. Now that means you can have a hollow, right, upper top plate that has this going down into these empty areas, right? And then that can help support with these two cylinders, essentially, like a rod cylinder and another cylinder, ceramic, right, wise. But then this, of course, happens to need your necessary outer side, kind of like stick welding, right? Uh, thing, right? Like a plating of paint, ceramic coat, whatever the coat is that's going to diffuse with the metal, you know what I mean? Right? So, like, this is intentional because the ceramic is supposed to be able to handle the heat that you have right now. So, you need to be able to make sure that that ceramic that you're making at home happens to go up to that high of a heat. But see, the thing is you don't really need to go that hard. You really just need the first initial burn to get it into a structure. Then from the side, you can get these PVC pipes, but you just need to drill in like a hand drill, right? Like these little holes that go down. They just need to be a little bit, thicker sidewall material, right? But they need a bigger inner diameter. You need to flow some air in there. You need to put some stuff in there. It needs to burn, right? So you're gonna put some holes on the, side walls of your molds here, which are your ceramic, right, pieces. So that allows for everything to burn in from the sides and go up. All right. Now we want to start off initially with not much, but just burning it at the top and letting it go down. After that, we have to side feed it. We have to keep it hotter. You're only getting it initially done, right? Then we have to reburn. But the way we have to reburn is we have to place in the necessary metalloid ceramic, so the right material, right, as it'll bake into your ceramic that you're making here. Okay. mold, that is. Now, that's pretty easy to do. That's the nice part. Okay, like that's not like the harder part. The harder part is making sure you don't have it crack, right? So, when you do stop burning things, because you just need to get it hot enough, right? And you need to let it slowly but surely, yeah, get lower and lower temperature, and then you have to reheat it again. And then you can finally get it back to normal temperature. Now, the reason for this is because fuck you, basically, physics. It likes to go through internal stresses and it has like a whole bunch of, you know, insulative properties. So it doesn't really get to the temperature that you want it to. It'll take an exceedingly long time, right? But it did get to that temperature, not from the outside. It sustained the outside temperature for this long. We know for a fact that that means it can get towards the center, which is a three-dimensional thing, right? Your density, like all that. So if you know about your thermal coefficient, right, of conductivity here for the amount of distance and how long it will take for energy, heat to eventually equalize out, at which a certain point it won't. Yeah, that's the thing. So here's why you have to be careful when you make this. Right here, this cannot be that thick. It cannot be that thin, though, but it cannot be that thick. That's the thing. So there's a middle ground here that's the right size. And you still have to effectively burn something in that works its way in because of the plasticity, glass-like nature that is the surface of this ceramic, which will slowly work its way in to the thickness that you have. So you have to keep doing it. Even though it's cooled a little bit, you have to do it again. You have to allow for that heat from the inside, which is still very much less than the outside, as it'll cool off, right? But then, oh, yeah, it bakes in, kind of like letting it rest, right? But, oh no, that cooled off a lot faster. Yeah, so you need to get that to definitely be hotter again to even this out. That's the whole point. Yeah, that's the next burn. You have to do that. Deal. There's no escaping that one. Deal with it. So, if you know that, okay, then you know that, hey, cool, that's great, but also now it's done. So, here's your refractory material on the top of your plate, which is really just the two things already kind of close together, clamshelled, right? And you have to have your holes anyway, so that way you can drill in. That's a whole thing. But that allows for you to stick these things already in as you pour it in. Okay. That way it acts like a stopper. But as you pull it up, because it will be a thing that you have to do, you have to then push it back in. This forms the start of like everything. You're getting your sleeves going, you're getting your bottom kind of rib cage bearing area for your crank shaft. Yeah, that's what that kind of looks like, right? But it's not, we know, blah, 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 whatever. Point is, you're getting that done. You're getting your bearings, you're getting your everything that you kind of need for a scaffold to a block here going. Now, you also have the top of your head, which is a thing. You need that. You also need to fill along not too much of the sides, but some areas, kind of another rib cage kind of thing, right? Those are kind of like bands now, right? Now that gives us the rest of the volume to be aluminum, which can now be made even actually lighter with boron, okay? And a little bit of, well, good, well, because you need some flux basically. So, like, you remember, we're going to remove the oxygen there pretty darn well. So, hypereutectic is pretty good too. And magnesium is what I tended to use myself to get that damn stuff to bind to the carbon, high carbon steel, right? But that meant that the boron had to be within those areas, and we needed a silicon carbide as a part of that, so the carbon will bond with the carbon that's actually in your aluminum, as you can put silicon and silicon carbide that is, together, right? Now, it's not too hard to do that if you have a microwave kiln. Make your own silicon carbide. Here's your cell phone, and that's enough silicon right there with any of the graphite you want. You just get the ratios correctly, and you just heat it up for long enough period of time. Yeah, there's a couple other steps there with like have you you have to heat it up again, and you need to do like argon again, bath treatment, sort of how that tends to work. But that means you get a sintering, and it's silicon carbide now. But you have to worry about it binding to your microwave kiln because some of them are made out of silicon carbide. So be careful about that. All right, moving forward, you could also just buy it. But I almost guarantee you have enough like wood that you can burn, and you have like old cell phones or a computer or something like that in a microwave. And this is like $100 for a microwave kiln that'll work just fine for this. So I don't know, man. Seems fine. You got to get it to start kind of temporary binding wise, and then you have to go through like another flux run. So as you go through a gas that you have to put in, that removes like its temperature barrier and its electrical catalytic like barrier here to coming together into becoming silicon carbide, right? But then from there, we want to consolidate that, and that's the sintering process. So that means a third and final heating has to go through. And typically, you want to do that under argon, and you want to seal that in such a way that you can pressurize it, since it'll pressurize itself anyways as it gets hot. Just leave it there, basically, just under a seal, and it'll do it. And that's all you need. So three cycles, and you got silicon carbide on your hands for way cheaper than whatever the hell that was going to be. Look at this ginormous pot I can make now of silicon carbide. I have so much silicon. I mean, I can absolutely easily get rid of all the copper and other elements here in this just by basic chemical washes, essentially. You know, it's not that hard, and a little electricity if you don't want to use like the super, oh my God, I need to be a chemist chemicals, you know what I mean? So like run some electrical current, DC to AC, depends on how you want to go about that and what your liquid solution would be, right? Either acid or base or something similar, right? But that's what that is, yeah. Look that up, please. Yeah, look, do that. You're gonna need to do that. This is already dangerous enough. I know what I'm doing. Uh, don't don't just believe that you know the same amount as I do. I've been working on this for a while. I'm smarter than you. That's how that works. So like chill with the whole I believe I have the same amount of knowledge and confidence as you. No. No, you don't. Please look this up. You can absolutely do it, but please just a little. Or maybe not. I don't know. You do you. You know what I mean? Whatever, right? You know, but I have no liability. None. Deal. I don't want any liability with this shit at all. Go away. But despite the laughter and so on, right? It's still what it is. We have to do the naughty, terrible thing of saying, right, depending on how you want to do this, um, this will change dramatically what you're going to run with for your high carbon alloy steel. And molybdenum, while it works, is really pretty nice. The reason why I use the diamond like carbons because the allotropes would break away and then they would form naturally in a better poly lattice structure under that heat and pressure. And that condition where, as I ramrod it through, sure, it spreads that open and tensions and diffuses it, like it rips it out like a bread dough, if you will, right? And allows things to get in, sure. But I'm also electrifying it. That's the thing. Eddy currents are really nice, but also like just getting it going in, like I have to electrify it because it's, hydraulic fluid, dielectric, it's an insulator. So like, yeah, you can keep this quite well insulated, right? And you can still run a pretty damn high amperage and current through this because it's a big graphite kind of outer shell that I'm using myself. Granted, I did infuse in that a boron nitride, okay, and tungsten powder mix just because it's easier to get it to kind of be stronger without needing to fucking somehow forge weld this thing. It's like very little amounts of plating that I would have to do. It just needs to be within the area, kind of ram it in a little bit, electrify it just a bit. Then it's more about after that consolidation through a microwave kiln. From there, it's just like good to go. Yeah. So easy stuff, but it's really smooth and it's really nice to be able to allow for it with that tungsten and carbon combo with a boron that got doped. So boron's a semiconductorable material like nitride, boron nitride. Well, in this instance, it's very useful for helping make it be a little bit better at higher thermal conductivity ish, but really more electrical conductivity. Here, it's more about it doesn't move much. I don't want it to expand. I don't want it to contract. I want it to be very good at being able to just push through. Remember, this is all just like clay right now. We're just molding her in, essentially. We're just continuously cooling that area where we're running electricity through, and that goes into the aluminum around. Now we can ground that because aluminum is a lot more electrically conductive when it's hot like this. So that allows for us to undergo pulse width modulation into this based upon the rotation, perhaps, of your crank. I didn't use a crank. I used hydraulic rams in the right, arrangement because it was a lot easier to just kind of stick them all together, and make them a lot stronger. And I was a lot less afraid, and I didn't have to be near it at all. Nothing had to rotate in any way except for the pump that was way over here, and I would totally be able to not have it die and lose that and all that. Yeah, but I still have to get a hydraulic fluid pump, which is like a lawnmower and a couple of electric motors, box fans, blender. What is that at Goodwill? What you got over there? Get a couple belts together, right gears, 3D print, nickel plate that shit up, get it done. You know what I mean? Pretty simple stuff. Sure, there is some loss. I get it. Don't care. That doesn't matter. What matters is that it's quirky enough and it flows enough that it works. That's it. That's all I want. So here's the batteries that we have to have, which are kind of not batteries because this is an electron redox flow in a way. Yeah, this one is a bit of an interesting one. We create a bit of a circuit as it goes through the thermite reaction that we have going on here, right? So we can now absorb all that electricity as it tries to do work energy. We can power everything. Now, I just talked about how to make that, so you probably know how to. So we're gonna have an outer box that we put in all this stuff around, right? We have to put little tiny holes near the bottom, little shoot holes, right? Then we have to fill those up, which that's fine because I mean, here's a plug of like graphite or whatever the hell it is you want to plug it up with. It's just kind of fucking, we have the refractory. It's like, right, like fucking, I don't know, what is that? Some pine needles? You got grass over there? You got some like, what you got? I can just put a little mud in here, just bake it a little bit. You know what I mean? And I just gotta put like just a little quartz fiber up in there, and it'll basically outperform all of your shit. And now it's cheap. Here's some rocks that you got from the side of the road. Wow, works a treat, doesn't it? For all those naysayers so depressed, why does this continue to keep working? Well, here's your RTV if you want to add it in, which will bind with that. Right. But like, hey, that's for longer amounts of time. You might do this one time, maybe. You know what I mean? Like, this is a whole fuck ton of setup for one single moment of doing this. My justification was like, oh, I got a hydraulic ram that spins, and I can totally put a pour on that and get it way better. Yeah, I can get this real honed in. You know what I mean? This is perfectly straight, doesn't move. I can get all the pores that I'm looking for later. I can even electroplate it basically off of that by having the flutes I can create. Just wear away onto the damn thing, right? Which is kind of what we're attempting ish to do. You got it right. So that tungsten will move over into the inner cylinder sleeve, but that cools it. That's a good thing. Now from here, that shell will radiate outward as a nucleation point for all of that is your carbon. Now we're not using diamond-like carbon because you unlikely will want to buy that, right? So like, just a little carbon, right? And then like, whatever alloy that works best for you. So chromium, molybdenum, I get the chromoly desire, right? You typically do want to do a little bit though of something to make that work a little better. So boron is actually still pretty decently good at that. Boron nitride will work, it will sustain under the heat, but it is effectively micron-sized little bits that are just in it. They didn't really do much. That's kind of the problem. Nitride is sort of the issue. If you don't have the right other compound with the nitride, it doesn't break. So you need that to actually happen. Yeah. Sort of a problem. Zirconium to alumina will maybe do it, but alumina is not worth it. So instead, zirconium might, but it's expensive. So, right. Um, which is one of the reasons why I just sort of didn't do that kind of version, right? Like I got some chromium, I got some molybdenum. I went with the stainless steel, hardenable stainless steel, because copper is already from the silicon I can get. You know what I mean? It's not that hard. If you look up the ratios of those metals and materials, right? You can find out, as I did. Yeah, all the ones that you need, and you can get all of them. So there's that. I added nickel. That was my thing. It was nickel. Yeah, I use nickel. Um, because it's pretty easy to get a hold of. So there's that. Um, Cobalt is not a good one. I don't use cobalt. Please don't use cobalt. Cobalt is very dangerous. Please don't use that. It's extraordinarily dangerous to work with cobalt. So there's that. Often. Yeah. It's very toxic and carcinogenic. And in fact, tungsten's not, but tungsten carbide will be. Yeah, so I found that one out the hard way. After, fucking using this 1200 grit diamond lock for knife sharpening. It's got diamond, right? To flatten my tungsten carbide volcano nozzle. So that way it was like properly gonna fit. Even though it worked just fine, it went right through the hole. It was all good, right? I went, no, I just want to be flatter and I want it to be tighter on that seal. Yeah, so I left it alone and just kept that going, right? But the point is, we're gonna move forward from there to, hey, guess what? Now that's a good initial start to the mold, right? Well, yeah. Well, right. So wait, what? Yeah. So as that plate is up there, that means we can now move this over and connect it to those hydraulic rams and go, all right, let's see. Let's try it out. Yeah, let's give it a shot. Okay. Hopefully, you know what I mean? Like we gotta try, right? Now we have to experiment before. So if these rams have these things in the end, we know we're good. We don't have to worry, bro. We good. Let's go. If you don't, well, you're fucked. Well, you fucking stupid. What the fuck are you doing? Oh God, is it gonna work? Does it? Did I do it right? I need to practice a little before I do. Ah, ooh. Right. So yeah, two ends and it's very binary. You don't get anything between. You either don't care, which is still on that other side. You're just not aware yet. It all worked out. Oh, did it? Looked at a hole in your fucking goddamn backyard. Holy shit. Big old pile of fucking metal. It's been so long, slowly but surely oxidizing it. There's a whole thing with manufacturing, actually. That was what that was for. So it's like I needed material, I'd buy junkyards and dump stuff, right? And it's like, so chemical from dump, like taking care of garbage and acids, bases can, be used, and then I can get sewage, and then I can buy a junkyard, and the junkyard allows for me to have all this extra metal in part stuff. So I combined and make sure chemically and electrically everything worked together to give me everything I want at the end. So it's a whole thing. But anyways, nothing like recycling, right, guys? Could have made a bunch of money. Anyways, we're gonna talk about how, like, as cool as that is, sweet. Now we got like this cool thermite engine, right? And it's like, well, you have to get it to do not. So we're gonna get there. So we have to get these transducers, which are along the side, which they're really just big old vibrators for concrete. Turns out if you shape the vibration the right way, right, it changes its frequency as it gets delivered. So like there's like a way to connect that to the sides of the box to then allow for, as the liquid aluminum is currently there, right, we can also get the non-liquidized sleeves and of course bearing bottom crank. Uh, So the bottom crank area, I went like, yeah, higher carbon because it's likely to diffuse and then like break apart and then rush down. Unfortunately, yeah. So I'll just go with like there's more iron and carbon in that area versus over here, right? But I'll have more than enough to make this work, so long as I can make the two mold halves that I need to make, right? Now, that does mean, though, that there are holes along the side here that has to connect to that cylinder sidewall that have to act as supportive structures. Now, those flare out, basically, right? But that means that there's other areas in between those areas that make sure the metal will flow correctly into those areas. Now, because aluminum is quite a bit less dense than iron, it will float onto this. Okay, like it's not going to ever really do anything, right? And yeah, it's way less heat, but that means it retains the heat in the sleeve and the bearing area for far longer, especially with the top where your head is. So this would be a closed because closed is far and way easier to make. It's just one closed top. Yeah. So instead of having to make a whole bunch of holes or any of the run thing around, the supportive structure underneath can just hold this, plate, and then like that just needs to be where it is. Yeah. So we can now get the aluminum where we need it to be, and from there, we just have to run the electricity the right way to slowly but surely continuously ramrod this and align during those vibrations all these crystalline structures that we're going to create. And that creates spiderweb filaments that are kind of like in a vein in a mine, if you will. Yeah. Now, geologically, if you've ever seen that, great. If you don't, spiderwebs that are kind of like a sponge, if you will, or something. I don't know. You know what I mean? Like that kind of thing. Yeah. So you get the germ gist. Yeah. But there we go. That allows for then the aluminum to actually bond throughout in a lot of places. Yeah. So now you can have your ports that are iron with aluminum around it, right? With your heads that you can also cast that doing the same way. Same thing with your crane case if you wanted to, but here's the consolidation problem. We always have to do this. This is the ouch of it all. Yes, there is an ouch here. So you're going to get dry ice. So after this is done, it's cooled to room temperature. You're going to seal off that top. Remember that whole like heating thing? However the hell you got that to be sealed at the top and insulated enough, right? You're going to bring that back out. It's gonna have to be a thing. You're gonna have to do it, okay? Right? But from here, we're gonna put in dry ice. Then we're gonna get out liquid nitrogen. You have to buy. Yeah, you're gonna have to buy some liquid gases. Basically, you want this to get pretty darn cold, actually. Here, and it's gonna take a lot of dry ice to do this. It's a fact. Yeah. So more insulation, definitely, right? But that's a good thing. It's gonna take its time. So plan like a weekend. You're gonna leave it overnight while you sleep anyways. But that does mean that you have to get a lot of decent amount of dry ice and slowly let it work its way in after it's kind of fully almost completely sublimated, right? You want efficiency, but you also want to deal with the fact that like that inner area, it's just gonna take forever to cool down. Yeah. So yeah, it's one of those things where if you get it the longest amount of time before you have to put something new in, you get more out of it, right? And you give it more time to know where it's actually at temperature wise. So from here, can fully get it to that dry ice temperature, and then we can get to liquid nitrogen temperature, which will take probably way longer. Yeah, dry ice will be like a good amount, but you're gonna need a lot more liquid nitrogen just because it's gonna take a while, a lot longer. Like dry ice is nowhere close to liquid nitrogen, but that's because you want it to be in a bath of liquid nitrogen. So, depending on the size and scope and breadth of your cast, total literage, you have to fill in that volume, right, with liquid nitrogen. Yeah, that's going to be a bit of a brutal thing to do, but don't worry, you're basically done now. Yeah, I'm not kidding. The only thing you're going to need to do is plug up the side holes by just throwing in some dry ice every so often so it sublimates out slowly, right? Because it's going to go from really cold, and we want to make sure it doesn't boil off too quickly, effectively, right? So as it gets getting to starting to boil a lot more, we want to throw in dry ice. Now that allows for it to much more slowly get to the point where with the dry ice as the final one, as there should be no more nitrogen there, we now have the ability, right, to go, all right, I'll just warm up to fucking room temp. I don't care, bro. I'm out. I'll get to it. This was a whole freaking project. Uh, so, nah, I'll get to it. Yeah, it's gonna take some time. Yeah, give me like a week or something. It's a heavy. I need a cherry picker. I have to get like a little wood things, and track it over there. Hopefully, it's all good. Hopefully, you remembered good mold release, like boron nitride, if you will, on the outer sides or inner sides of your molds. Because you have to lift up the top mold, and then like the thing underneath will be there. But of course, that means there's different expansion and contraction rates. That's one of the reasons why we had to cool everything. So not only is it bonded, it also should have very close to similar thermal expansions once we get it cooled. So this is the consolidation. This is like effectively hardening and then tempering all in one. We get it so cold that during this, it undergoes different levels of stress and strain, and it's allowed to move its electrons and its atoms and its structures molecularly around such that they form a more ordered and more corrected in terms of at least under tensional state, if you will. Right? Like it's under tension from before, and as we cool it, then it will use said tension to move itself around to while it's cold into place that's better for it. Yeah, and then as it goes back to being warmed, this is an annealment stage that allows for that tension from outside and changing, of course, that thermal expansion rate to be treated over time to equal your best result. Now, from here, we then have to go through a reheating cycle. Yes, I know, it's tedious. I get it. Here's some reflective sun stuff. That's all you need. Here's some mirrors, literally just fucking point it into the hole. Just open up the top, point it in the hole, put some argon around, put like a sheet if you need it or something, so that way it stays in there, right? But you don't want it to oxidize. This would oxidize pretty fucking bad. You don't want to do that. So instead, you put in argon, as the CO2 will eventually be removed. The CO2 doesn't really react very much, so you only need like a little bit of argon, because the CO2 will still remain around. Yeah. So from there, whoosh goes the heat, basically. Yeah. Now, that allows for a greater degree of movement to relieve the tension. So you're only going to get it to just above your operating temperature room, meaning if it was to ever get to 250 degrees centigrade, then you would go to 350, right? So depending on your thing that you're going to do with this, which this is an engine, so we're going to say it's 500C, as that's pretty easy to accomplish with a little bit of light. We don't really need to go even that hard, to be fair, right? But you know, I didn't. We went with light, and it worked just fine, honestly, because we have other tolerance and so on finishing things to do over here, and that'll help it later. But if you want to get it done all at once, you can do that, and it'll get you everything you're looking for. You just got to let it slowly cool back down to room temperature what the outside is at. So as long as it's not in winter where it's like -30 C over here or something like this, -80 degrees Fahrenheit or some BS. Ah, I'm gonna die. No, don't do that. Bad. Point is, yeah, no, it'd be quite cold. Please don't do it when it's winter. I know you have a desire, most likely, because it's going to be quite warm. Spring or fall is just fine. You don't need anything other than that. That's the facts. Okay? Right. Now, from here, all right, we're going to go with, hey, you're pretty much done. You just need to do a boring with your electrification plating process. Because you need to consolidate this, remember, in a slightly greater degree than you thought. Yeah, so this still has a charge value. It's almost like it's alkaline right now, right? Because we cooled it, yeah, but also because for what it's worth, how we went about this, there's a lot more electricity than should be there, and we need to yank it out, right? So what that means is we're going to induce a field, an electromagnetic field. We're going to kind of try and heat it up a little bit, but then we're going to have it basically be a collapsing electromagnetic field to try and create an increase of voltage. But that just means it disturbs some of those outer shells for a little bit, and then we're going to grab that by having a ground on the other side. Now, this ground is actually being lowered with a little voltage necessary to do it by plating. That's right. This wants an electron. You have one, and I gave you enough energy, so you're going to give it that electron. That's right. Good on us, right? Now, from that plating process, which is really only for the cylinders and the bearings and other areas that you kind of need it for, like the top of the block and sides, basically, right? Because you can't really get all the way up in all those places. You're just trying to get it to correct, specifications of tolerance, right? So it's only plus or minus this amount of thou or micron or something, right? That's all you need to do. So from there, you're good to go. You just got to cross hatch where you need it to be. You got to bolt them all together. So tap and thread, bitch. You know what I mean? Get it out. Let's go. Come on. Unless you put that in your mold, in which case that's pretty amazing and impressive considering like threaded in a mold, a cast mold is pretty hard to accomplish. And it's gonna be really hard to probably take it out, I would imagine, of the mold because those threads are like frictional gear teeth, basically. You can make little tiny ceramic, bolts. 100% it will work. Just that make sure to coat that the right way. Please do, yeah. Because otherwise it will not work. Anyways, um, from here, yeah, you're good to go. You just got to get your crank. So, like, if you know you have a crank ready for this, sure, go for it. But if you don't, here's how you can cast a crank and turn it into a hardened and tempered, better than a billet could ever hope to try and accomplish to be. Crank. You can put different materials and structures in it. Depending on your mold and how you decide to cast in with this thermite, you can get many better materials that are much lighter, much stronger, and much more uniform the way you want as you vibrate it and you electrify it and you cool it. Cooling acts like a hardening. It's not a real hardening. We know that, but we don't want that. That's the thing. Like, if you do it this way, you don't need to harden it. You don't need to pound it together. For our purposes, it's hard enough. And in fact, sure, I can get it harder, but I really don't need it to be that kind of brittle. So this gives us hardness while reducing our brittleness. There's a sacrifice, of course. Yeah. But that's good enough because you can still harden the outside if you really wanted to by extra heating it in one little area and then rapidly cooling it down, which is what you're going to need to do anyways. Because, yeah, bitch, you thought you have to plate this. And so you have to heat this up and you have to slowly, in no real way, I mean, it's pretty fast to be fair, get your bearing surfaces on your crank. Yeah, where your connection rods go to. So these are going to be really super dang duper smooth and correctly bearinged surfaces. But that usually requires you to get it pretty decently hot there. That's kind of a thing. So the surface will be pretty decently hot and hard after you plate, and that rapidly can cool it down. Now, that requires a sacrifice of knowledge called chemistry and electricity knowledge. Nothing like a little light, right? But like, no, if you're not good with that, you really probably shouldn't do that one. That's quite dangerous. A laser etcher would not really work for this. It would very, very likely hurt this in you. This is the whole thing. Yeah. So, and that's not even getting into the fact that we need it to be larger, kind of like those de-rusters that you see, right? But that means you have to scan it in a given area fast enough Right, and so you have to know how to do that. If you don't know how to do that, please don't do that. It's quite dangerous, yeah, because you're gonna electrify it anyways, right? So you just need like the right little plating wick. It's essentially the equivalent here of like, a MIG welder, but it's in the right way with the right material on it. And so while this gets hot and you energize it, this will automatically sweat it on and rapidly cool it. Well, of course, you do have to get it hot enough. That's the point. Now, that just means it fits into gaps and slots and so on that are molecularly and atomically there because it's quite warm. But then it rapidly cools. I have to keep telling you this. It's chemistry. Yeah. Which is why we use an electromagnetic induction. It's much easier. Yeah. Like, right. Simple as can be. It's both coils the right way. And it works pretty darn well. I have no idea what that was either. Something fell. I didn't see it fall. So there's that. I have no idea where that is. I think about my dog just laying over by the door. Point is, though, we're going to move on to there's your crank, there's your bearings, there's your head, there's your bearings and your valves for your head. There's literally everything you need. Like, look, these are two iron parts, but they're not. They're really steel at the top of your block and then the bottom of your head. The rest of it's aluminum. Because why else do you need anything else? Like, oh, you need those little things that hold your camshaft up there, right? To be iron and really nice and strong, right? So everything else can be much lighter material. It's like, oh, all right, I'll sand these two things together into a fusion bond weld during casting that will absolutely make it harder and better by never using any traditional techniques that have stood the test of time because they're shit. They couldn't make this block. You couldn't ever make this block. But guess what? Now all of you can make this block like I could. All of you can easily make a much better fucking crank. Every piston head, every fucking connection rod, all of your own bearings. And all you had to do is wait around and oxidize some shit and learn for a while. Dig a hole, save up some money since you did it so cheaply like this. Some dry ice and liquid nitrogen, maybe. That's all you need now. Isn't that great? Granted, that means you need to follow through every step of the way and continuously work on it. If you're rich, then it's like, oh yeah, I just have to look this up and then buy a couple of things. And I don't have to do a damn thing about any of that. I can just immediately make it. Oh, really? You don't say, huh? Must be nice over there. Wow, dude. I know, right? Yeah, still, that's their life, not mine. As I'll move on. I don't really have to care. What I have to care about is getting my own ass to get there. That's what this is about. So, here, if you want to know how to thermite this, not that hard. You want to know how to fucking make aluminum get bonded to steel properly? Well, there you go. You want to know how to make a better engine than anyone else on the market right now could ever possibly be bought? Well, here you go. You want to be a part of the blue team, the broke bitches? Here you go. Get smart. Be part of the blue up in here. That's right, Nolan. Yeah. Get wrecked. Don't immediate. It's the whole thing. Point is, that's what I'd be doing. I'd be like, oh, really? You want me to do one now? Okay. I know all about how this fucking valve works for VVT, VVD, and VVL all together. I know how to cast this easily. I can make every single camshaft. I can do whatever the fuck I want. I can make an entire shell. I can make my entire frame. I can weld this without ever needing a welder. All I have to do is get a bag and some electricity and chemistry. I can make the entire thing exactly like I want. You think Mystery Machine would have fucking lost? Oh, pish, piddly posh, bitch. I got double stroke link tech. I got fucking goddamn. Look at these. These are rocket injectors. I literally burn air and fuel into my fucking cylinder. You want to know what a double stroke link tech is? It's a valve in your piston head. That's all it is. I got a bottom to your bearings for your crank. That's right. That's all it is. Literally. Pretty fucking simple shit. You know what that means? All it does is it goes, hey, here's some oil. Yeah, it goes up from the outer, right? But it's still the inner. So like, yeah, two tubes here, right? A tube inside of a tube. Yeah, yeah, I can never understand that. Bullshit. You can. You can fucking understand this. Deal. So, goes up, right? But it's like, hey, guess what? Remember that crank? Yeah. Remember that connection rod? Yeah. Well, it has to be a hollow tube, remember? And we have a bottom. You're going to have your 6 fucking compression rings and your 1 oil retention ring in the center. Offset them. Standard 180, right? Goes up from the bottom. You already know where this is going. Oh, I can never use oil pressure ever, ever to fucking move a valve. Didn't you just, what, hydraulic fluid ramrod something, you little dummy dumb? Are you insane, you little stupid? You really think that's going to work up in here? Nah, we know you know how to do this now, you little dumb. You know what this is. This is easy as shit. Not hard, you little fucking what? You want to say you can't do this? Why don't you get some positivity in your life, you dummy? There's no way you can't. It's a fact. But we already did it back in the 1800s for these fucking radial engines. That's right. This is a 2-stroke radial. They just fucking they already have this whole thing. You're wrong. It's already been made. We just made it better. How fucking stupid are you? You think this can't be done? No, I didn't like that. Oh no, look at this little hump in the center. I have a higher compression ratio because what? I can run mostly fuel and just burn air in. Or I could just go like, I'll just lean it out and then throw some more fuel in. Look at my ducting. Yeah, I don't have that. No, I can't use ducting. There's no way. I can't use any of this. There's no Bernoulli principle. There's no throat down further. There's none of this chamber. I can't use this. My injector didn't already come with this. No, I can't build this into my head. How stupid are you? Fucking really stupid. That's what you are. I need valves. I only need valves at the bottom. What is this? That's the only poppet valve I need. Oh, no, my camshaft at the bottom. Oh, whatever will I do? Yes. Use it as a pivot spot for an offset crank. Help shoot that oil up in there. Oh, yeah. Let's go. Tune that bitch off my camshaft, brah. Rotate fucking, oh yeah, I got my fucking inner. That's right. Piston head. Valve tune, baby. VVT, VVD, VVL. Oh yeah, let's go. Gonna do it. Let's go. It's like, why not? Why wouldn't we? Like, that's double the stroke length. Why wouldn't I do that? Yeah. Fucking easy as all day can be if you wanted to do it right. But granted, that does mean this is a slightly larger injector, right? There's air and fuel into that one, but we have large injectors. We already have ginormous diesel ones that are solenoid operated. We don't need to use that one, to be fair, because this, we don't really, they don't need to be that big, like at all. This is not a thing. They just need to be robust where they need to be, where air and fuel is burning. Yeah. But you're going to cool it with, your fuel return, basically. Like your input fuel there is going to boil off. Like, deal with it. You're going to put it back into your tank. It's all good, whatever. Here's your like little cooler for your fuel. It's a nice little, like an oil cooler. It's a little tiny radiator guy. It's not that bad, right? Deal. Okay. You condense that sucker back in, make it happen. Let's go. Right? Simple as it can get. You just need enough air pressure initially. So here's your canister. It's called like a scuba tank. I don't give a fuck where you got it from. Just get a tank. You fucking built the engine. You can't get a tank? Come on. Are you what? Are you serious? Here, here's some fiber you got lying around. Here's some plating done. You have to weave it the right way, literally. God, this is as simple as it can get. Oh no, my anchors that keep my fibers around so I can plate and then ultimately fill all of the fibers in with this plate that's forming it into a fucking cylinder with fiber reinforcement under tension. No, I could never use that. That's hard to do. Carbon fiber, anyone? Quartz fiber up in this bitch? Let's go. It's hard. Why? You can't just buy one? Why not? Yeah, it's all up to you. How much money you got and what you want to do. All right. Of course, I'm going to do the little Matthew Illiard, like, look, man, I'm not screaming. I'm really not. I swear. I swear. It's the whole thing, right? Because, like, I like to do that. It's fun to just shit on people that say it can't be done. It's already in my other video. You just never watched it. Part 2? Look how lazy you are. Look at this stupid shit. How can you fucking look at yourself? You got, like, over an hour in. You're like, poo-poo on the idea it can never work. You get to this point. Are you sure? How does this work? You just skip forward to this shit on someone, didn't you? You fucking evil piece of shit, gabagoo, motherfucker. Get the hell out of here, Get the fuck out of here, dude. You get this done. So it's like, here's your tank, right? You're just going to pressurize. You're just going to use compressed air. I know. Look at this air compressor. I can never find one. Oh no, look at my check valve. I can never have an intake check valve area for the cylinder. Oh no, my super turbo. Whatever will I do? I could never use that to compress the air in enough of a volume. Why are you alive? Shut up. I already talked about this so many times. It's easy. Why is this hard to you? You can never get compression. Look at my AC compressor. I could use that. It's electrical. Literally, I can do that. It is more than enough. I just need like 2 or 3 of them. Here's volume. Here's higher pressure. Here's your third one for both, basically. Yeah, you get your compound set up with your 2 in a compound. So it's a compound to a series. So, basically, yeah. But like, whatever, who cares? You get the general gist. Like, here's this works, this will do it. You don't need anything else. Like here, you can dynamically change what your cylinder pressures are. That's the point. Like, hey, no, I only need like, top dead center, initially 500 psi. If I keep and maintain 500 psi all the way down to near bottom dead center, guess what? I have the bottom stroke now. That's like a lot of extra fucking pressure, bro, as it opens up that valve, bro. And then it goes back up and it goes faster, you know what I mean? Goes back to accelerating up. You know what I'm saying? It's like, oh no, did my valve open and the pump valve at the bottom here? Oh no. Oh, no. It's called a bottom, not a head. Dumbass. It's hard to do. I already just said that. Like, that's difficult. What is this? Who are you? How stupid can you get? Shut up, man. I got a point here that's technically not even a bearing. It just goes through. Yeah, but it's sealed more than enough. It's a bearing now. That's all I need. I can get a crankcase vent. That's not that bad. Come on. What's the big deal? Like, look at how much extra torque I just got. Double stroke length. Don't even use nearly as much fuel. I burn it more cleanly because I have ducting. I need fewer amounts of it, and it does more work. I'm more efficient than you. Oh no, my turbine. Oh, what's that? Is that electrical generator? No, I didn't do that. Shut up. That's what you sound like. Should be quiet over there. You can't do this. Get out of here. Look at my. Oh no. I cast this whole thing. I did this whole thing. I can't make a radiator that has piezoelectrics in it. I can't do this. No, not my Diaphragmic piezoelectric cooling. Oh, yes, yes. Right, so it doesn't need to bend here. So this is pyroelectricity, technically speaking, except this is to deal with the compression and uncompression of a spring-like material. You know what I mean? Right? And it generates, of course, a piezoelectric current, but of course that's done through heat and it moving through the air. It's like, I could never use that for my radiator and my exhaust. No, I'll just capture all of that as electricity. No, my compressors. No, do you suck? Oh, I suck now, huh? Is that what's going on? I suck. Ooh, get wrecked. I can maintain this engine off of almost nothing and dynamically load it perfectly however I need to, with the amount of cylinder pressure I need at any given point to always make sure it has exactly the amount of power it needs for any of the loads I'm going to give it. No, not my transmission. Not with piezoelectrics. Not with my springs and shocks. Not with my wheels. Not with my body of the car. Oh no, is that an electric motor in your differential, or are you just really happy to see me? Front and rear wheel steering. I'm going all in. I want it. 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 I want it, man. I want it. So there's that. But nevertheless, watch. As everybody goes, hey, tail faces can there solenoid. That's right. I put a solenoid in there. Yep, every single piston head, solenoid. Helper. I make electricity, piezoelectric in there, in those sleeves, yep. In my block. Fucking making that electricity every single time, every single goddamn fucking combustion, always. What is that? My injectors, same thing. Intake, same fucking thing. My tank, same thing. That's right, I'm never-endingly fucking more efficient than you. I have to get this, it's loss. Look at that. Look at this stupid cable. That's 10%. All the way down to this point, where then I can get it. That's loss. Look at this stupid loss. That's garbage. Why would I do that? Look how shitty that loss is. This is more efficient than you. Literally. Always. More efficient. My electric motor, by the way, yeah, do you remember these electrostatic electromagnetic ideas I had? You know, kinetic amplification guy and all that on my YouTube, right? No, I could never use that. Electron reactors flow? No! Breaking apart those nitrogen oxides. Burning air. Do I even need fuel? Here's your catalyst. Here's your electricity. Here's your light. Oh, burns, explodes, explosive decomposition. What is that? Oxidation and nitronization of various compounds in our air, making sure they're no longer pollution. Oh no! What are we gonna do? I don't know, just extend the duration of this refrigerant engine. That's a heat-based engine using chemistry as an amplification of my given design's efficiency. Prego chug, bitch. Ooh, spaghetti, still got it. Damn, man. You see what I'm saying? Like, that's as easy as it can be. It's not hard. But apparently a manufacturer will tell you it's something that's pretty difficult. But you know what? It's convenience. It's not that difficult. Each step is really not that hard. No. It's the fact that it's like, God damn, I don't want to do all that. I'd rather say that. Can you just do it? Like, God damn, dude. Yeah. Oh, you're getting, no, it's all doable. You just don't want to do the work. I know what you're doing. You're trying to slack, bitch. You're trying to slack. Look at you. You able. You got money. You got time. You got the space. You do. I know for a fact you can get it done. You a wimpy bitch. You a scared, sluggy dude crawling around in this fucking shrimp guy arms. You know what I mean? There it is. I'm in there somewhere. Got no fucking goddamn ability to get confidence. You always sad. You always deflating yourself. Look how possibly negative you are. Look at this. How are you going to get something accomplished? Oh my God. Think about it. What's your brain doing? What the hell, bitch? God damn. Live a little. Have a hobby. Why aren't you passionate? The fuck? In hell, if I had half of what you have, God, I'd be so much further in my life. Fucking hate you. Seriously, I do. This shit sucks to me. It's a bum deal. Couldn't fold that hand, have to make it happen. Fucking, oh my God, this sucks. Anyways, point is, yeah, no, here's your thermite engine. That you could technically, if you weren't a pathetic, lazy, weak bitch, make. You don't want to do the work, you don't want to get fucking built. Look at this meme. In your mind already, look at it. Look at it. Fucking. I did all of this. Fucking did the work. Fucking got no longer stick thin. Built, looking thick. Fucking oh yeah, muscle up in this bitch. But what you want to do? I'm stick. Fucking can't keep that around. Gotta have people around that actually want to try, with me. Understand that I'm actually trying. The idea is there, all that works. Yeah, they're smart enough to know that it works. Can't look for dumb, or at the very least, they like me. It doesn't matter if they know if it will or won't, they still want to support. I don't need them to be that smart. I need them to be smart where they're kind, loving, caring, supportive. Not you. You're gonna try and help make it work with me. That's what I need. It's a thing. Doesn't matter. Yeah, here's a thermite engine. It's a high efficiency thermite engine. It can do more than 90% efficiency. That's up to you though to get it there. Yeah, a lot of this is transistors that you have to make along with all of those nice platings and castings that you're gonna have to go through to get there. Right? It's gonna take a little bit longer, sure, but still, it's a very high efficiency engine that produces a lot of power. And it just burns the atmosphere. You just need electricity to start it up and a vacuum on the inside of your cylinders at the start. That's it. Oh no, my oil. What am I going to do with my piezoelectric oil? It's electrically conductive enough. Oh no, suck it up. Not my losses for pumping getting removed. And I'll get them back later, bitch. I guess you forgot about, I don't know, progress over time. Look at your fucking shitty schools. Progress over time is not a thing. Fuck that. You can't include that. That's not that efficient. Are you sure, you dumb fuck? Are you positive about that, you negative, toxic garbage piece of shit? Watch this. Boom! This is what you got? That's it? Look at you. You got nothing. You got more money and everything. Everyone around you. Oh, shit. Oh, why do you do blah, 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 dumb statements? What's this? You got money? Huh? You got people to help you, you little support bitch? Huh? You got friends, you little fucker? You going back to your abusers for everything, you little fucking fuck up? Look at you. Look at your thought process. Look at your mind. Look how garbage. Oh, just do it. Oh, no, I have a problem with task initiation. Yeah, let me just get going on it. Great advice, dumb fuck. Look how stupid you are. You thought that was actual advice, therapist? It's not actually right there. Although some of them have said that. Yeah, it's a thing. It happens. It's really just people online. I know you. Too many of you. You're garbage pieces of shit. Those that still make fucking videos. It doesn't change it. Some of you are worse than even that. I'm Alex rings a bell for some of that too. Good thing I cleaned that clock pretty fucking hard, huh? Oh, hey, did you get to the end of this, Alex? Could you have thought of it really good too? Is that how you fucking describe that? Really? You fucking retard? That's what you got? God. My Game Boy Cube, I made best decisions, don't need the money. I don't even concern. Look at how great I am without needing to do anything. Fuck off, man. Fucking lame. But that's the point. It's a good Thermite engine that's super efficient and you can burn the air into it. Off of pistons, I got to that percentage of efficiency. That doesn't mean that you have to get it warmed up and everything. Sure, you do have to do everything correctly, not incorrectly, like you're already doing. You don't know about thermophotovoltaics? You don't know how to cast those? You don't know, oh, where are you going? You know, that's piezoelectric with the fucking thermoelectric fucking material? You don't like that? Where you going, bitch? Where you going? You don't know about field effects? You don't know about, what is this? How come you don't know anything? Why you say it won't work if you don't know anything about it? Why are you a fucking idiot? Saying words. Look at you, you fuck up. You said something? You should go back into your little stupid box where you came from and shut the fuck up until you learn something. As has been expressed to me many, many times on Reddit and more. You'd think that they'd be good people. They're not. It's a whole thing. Man, I wish I could just ruin those fucking people. That fuck. It's not power. There's law. Oh, yeah? That's interesting. And you have a PhD, do you? I believe it somehow. Fucking loser of life. Every day, seconds last, you fuck up. Look at you. You think this way? What fucking point did you get to in your life to get to this point? Huh? To turn into nothing that should be alive at this point. You're not a supportive bitch at all. You know what you are? You're a thing that wants to make everybody look at you as if you're superior and you're garbage. You couldn't possibly be something. I would even concern myself with ever being correct enough to say I should stop. You are less than I could ever been in my entirety of life, regardless of any point that I thought was terrible. You are worthless to everything. Stop breathing. I have a fucking fission engine that here, right now, literally, just off of this, power crisis solved. No. We just do this again. Fucking yeet! Vacuums. Piezoelectric. Light. Air go through. Here's a little liquid. Quantum foam to absorb, yeah. Too bad it's gravitational. Most of that energy. For all of you, because it'll keep going for a real long time, huh? But like making a thermosiphon do way more work than it ever did before, at a much higher efficiency. Nothing like electricity. Oh, can I absorb a harmonic amount of kinetic energy? Oh, goddamn resonant frequencies. Holy shit, what about that field effect, bitch? As it goes through like a MOSFET matrix. Holy shit, do you even know about this? You worthless! Look at the transistor, you trying to fucking fight me, bitch? Look at this. Look at this, look at this, look at this. Oh my god, you don't know how to layer anything? You don't know how to fucking put inductive fields back together? Fucking make them run the way you want, capture them? It's not lost now at all? Why? You got 3D nowhere in your mind? What the fuck is wrong with you? Look at this 40 overtime resonant harmonic kinetic delivery of fucking energy. Look at this tunneling. Oh my god, I can't transfer that with field based fucking informational energy? God damn, sorry. Fucking got this superpositionally, getting all tunnel oneally up in your shit, bitch. My god, look at this! Proven! Another study. Told you I was right on Reddit. Ha ha, buddy. Still stacking. I got perpetual motion like energy. Goes on for quite a long time. Sure, I have to repair it a little bit, but that's okay. So do we. Fuck you. We got time. Holy shit. Look at these yottawatt hours. Like it's nothing. Oh my god. Look at you. I need to absorb that much. Oh, energy from the sun. Get out of here. I got gravity. I can control the weather. Look at everything I can do better. Why would I go with your Dyson sphere? Dyson? My ass, bitch. Like I need to do it. Look at this. I can control every goddamn bit of energy in your entire solar system. Look how fucking manic you are trying to go after me. Any little defensive bullshitty excuse you can try and make. Oh my god. What is wrong with your little mind? Shut the fuck up, bitch. Look at this. I got no time for you. I have shit to do. God damn. Sorry. Follow the rabbit, Alice. Do it. Are you in Wonderland yet? No? You never can be. That's what you made your society, you little dumb fucks. You're fucking worthless at that. This capitalism, where's it gonna go? Nowhere, because we don't need it. You have all the energy ever. You literally solve it doing this. And it's cheap. Right now, we can get it done. Literally. And you're arguing? You want to torture them? Ew. You're disgusting. Worth. Only a gabagoo. To die, be an example of what not to do. Garbage. You don't want to work on something, make it better? Not even yourself, you're perfect? That's why you're disgusting. I'm already better than you. You're perfect. You can be infinite, and I've gotten beyond you. You're nothing. Perpetual that can keep going beyond your infinity. Ooh boy, nothing like quantum energy. What is that constituent makeup? Momentum for us, maybe. But then what's the other stuff? Oh shit, we gotta wait and see. Gotta get there. Oh no, baby. You wanna go past Omega with me? You think that's the end? Bitch, I made my end. Never happened. Look at your immortal infinite. Already around you, effing you. Oh, yeah, you had to start from me, didn't you? Fucking, ooh, choking. Get right, still got a better fucking total universal law concept. There you go. Nice Thermite ending.